So I just wanted to make a quick video talking about how, if given a graph, how the heck would you determine what the absolute value of that function is? Okay, so some things to note when you take an entire equation and you absolute value it is that if y equals f of x, and maybe I shouldn't use a blue pen, so if y equals f of x, what happens with y equals the absolute value of f of x? Well, understand that your x values don't change. All that changes is any values where f of x is negative, so anytime f of x is negative, or we can think about it as if y is negative, so that shouldn't say y, sorry, that should say 0. So, or if y is negative, make it positive. So here, if we wanted to look at this equation, and we simply just want it, and if we called this thing y equals f of x, and we want to determine what the absolute value of that is, well, this is all going to stay the same, because if we plug in 3 for x, we get positive 1, and positive 1 would stay the same. Now, something cool about your x-intercepts, these are known as invariant points. So these are points that do not change if you absolute value something. Okay, so an invariant point is a really useful point to understand. Now, how do I start drawing my absolute value? Well, what's going to happen is we can see here that this is 1 and negative 1. So all I'm going to do is this point is going to pop up, and my y value is now going to become positive. So that's positive 1. Here, my x value won't change, but my y value will become positive 2. And then negative 3, well, that's going to become positive 3. And finally, negative 4, well, that becomes positive 4. And now you can see we can easily create our absolute value function given our original function. So, and then it will also just follow this trend here. So there is y equals the absolute value of f of x. And now, knowing that, you can really determine any type of looking equation based on what the graph looks like. So this one, if we call this y equals f of x, and we want to determine what y equals the absolute value of f of x is, well, this section is all positive, so it's all going to stay the same. But what will happen is when we take the absolute value of x, we're technically just taking all of our y values and absolute valuing that. So again, where are your invariant points? Here and here. So they have the same x-intercepts. So there's an invariant point, and here's another invariant point. But now we need to determine this section is going to now flip up. So try and choose a few easy points to work with. So this point looks pretty easy. It's at negative 2 when x is about 2.5. So at 2.5, we're going to be now at positive 2. Down here, we have 3 and negative 4. So at 3, we're going to be now positive 4. So this graph will continue up like this for our absolute value. Again, this is all going to stay the same. And then over here, well, down here we have negative 3 and negative 4. So at x negative 3, we're going to be at y positive 4. And let's maybe choose one other easy value to use. So roughly at negative 2.5, we're going to be at negative 2. So now we're going to be there. So as you can see, that's what our function looks like. So this is the graph of y equals the absolute value of f of x. Okay. If we want to move down now, we can do any type of equation now that we know this. So here's y equals f of x. So let's graph y equals the absolute value of f of x. So remember, anywhere where your y coordinates are positive or 0, it stays the same. So here, these all stay the same. So these are all also invariant points. There we go. And then from here, your vertex is a pretty useful thing to know. So we have a vertex at -1 and -4. So my absolute value function's vertex is going to be at -1 and +4. So way up here. Okay, and then we can roughly try and connect that. So let's maybe do a few more points. So at roughly -2.5, at roughly -2.5, we have -3. So at -2.5, we're going to be roughly at +3. Okay, and then we could graph this point here. So this is -1, so now it's going to become +1. So there's our 1/2 of our kind of upward trending parabola. And let's graph this half over here. So my y-intercept's pretty useful to know. My y-intercept's about at -3.5, so at 3.5, we're going to have a y-intercept. At roughly a little over 1.5, we're going to be at +1, so that'll be here. And let's get a point in between. So right at roughly 1, we are at -2, so right about here. And there's our y equals the absolute value of f of x. And again, you would never get something this difficult in Math 20-1, but you can really solve anything you want. We know, though, that this will all stay the same anywhere where y is positive. And then what's going to change is simply where it's negative, it's going to flip upwards. So this vertex will now pop up at 2, and this will come up like that. Let's draw that a little bit more accurate. And then this section here is essentially going to just continue upwards. So there's our 2 there. And there's our y equals absolute value of f of x. And this is really useful because then we can create piecewise functions if we really wanted to. Okay, so whenever you're graphing something, graph the original function because it's usually easier, and then just apply this rule to graph the absolute value of it. So if you have any questions, please ask, and yeah, try a few questions out on your own and see if you're able to do it.